Okay, kids, buckle your seatbelts. It is time to add the fretboard to this bad boy. And the fretboard is actually surprisingly complex. First, we have to define the fret positions, and that takes a bit of math. It's not hard math, but it's got to be done, and I would much prefer to adjust it automatically should we decide to change the string length in the future. There are a couple of ways we can accomplish that little trick. One is to work with SOLIDWORKS 2012's new equation editor and use it to define our fret positions one by one. Now, I am a big fan of the new equation editor for sure, so I'm pretty tempted to do it actually, but I think there's a better way. It's called a design table. Now, design tables can make life much easier if you use lots of equations to drive a model. A design table is simply an external Excel spreadsheet that can be used to drive the dimensions of your model. Anything you can do in Excel can be done in a design table, and that is a lot. There are practically no limits. Unleash the beast of equation-driven designs, and there'll be no stopping you. Since this is a SOLIDWORKS tutorial and not a math lesson, I'll be providing an Excel spreadsheet in the tutorial files for this video. Let's take a quick peek just to orient you. You'll see that the workbook has two sheets. The first sheet is all SOLIDWORKS will be using. If you're making your own design tables, you'll want to take a look at the help docs because there are some pretty non-obvious tricks to making this work properly. Click on cell A2 and you'll see that the title of the field is set to Family, all caps. This cell is the key to making this work. SOLIDWORKS looks through the design table for that cell and then uses all the cells to the right of it as variables, and all the cells below it for various configurations, but we only have one configuration. Across the top, you'll see variable names, one to define the string length by adjusting the nut plane location, and the others referring to the dimensions in your as-yet non-existent fret positions sketch. Don't worry, they'll work as soon as we add the sketch. Look at the second sheet. SOLIDWORKS will ignore this sheet, but we're using it to do the actual calculating. This sheet is where the actual math is accomplished. Essentially, all of the values in the first sheet are referencing these values. We could have done all the math on one sheet, but I just think this is cleaner. Okay, so let's save that design table in the same folder as your master model. This is important because the master model will need to be able to locate that file. Back in SOLIDWORKS, create a new sketch on the front plane and look normal to that sketch. Hide the neck profile sketch so we don't accidentally snap to it. Now we want to avoid cross-linked sketches as much as possible and referencing those planes instead of other sketches. It's cleaner, trust me. Create a vertical row of 22 sketch points, again, being sure not to snap to any external geometry. The spacing doesn't matter a whit, just get them out there. In this guitar, we won't have 22 frets. It's just, I like to include a couple of extras just in case we should need them for a future design iteration. Box select all of those points and give them a vertical constraint all at once. Now you can select the top point and make it coincident with the right plane. To dimension all of these points really quickly, grab the Smart Dimension vertical ordinate dimension. The fret positions are all measured from the nut, so click the nut plane and then out to the left to define the 0 datum for the ordinate dimensions. Then you work your way down the line, selecting each point in succession. The sketch should now be fully constrained. Notice that we have 22 points, but 23 dimensions because of that 0 dimension at the nut. That's a really important thing to remember when creating your design table. Anyway, our design table does indeed have a 0 fret value to account for this. So let's exit the sketch and rename it Frets. It's really important to get the name exactly as it's written in the design table. In this case, capital F, then lowercase r-e-t-s. Has to be exactly that. You might also want to double check that your string length plane is titled capital N, lowercase ut, nut, just like we've got it here. Now comes the moment of truth. Insert, Tables, Design Table. Set Source, From File, Browse, and then locate your Excel file. Be sure to check the Link to File box, very important. And whether or not to allow model edits to update the design table is really up to you, but I like to block those actions since I want to control everything from Excel and not vice versa. I hate making a mistake and then screwing up my design table, but that's your call. I don't want SOLIDWORKS to automatically add anything to my design table. It's already nice and clean as it is. So I'm going to uncheck all of the options at the bottom. I'm just a manual kind of guy, and I'd rather be in control than have SOLIDWORKS messing with my nice clean table. But once again, that's your call. Commit the change, and the sketch points should all jump into place. If you edit the sketch, you'll see that all the dimensions have turned bright pink, indicating that they are still raw and a little tender after the design table surgery, and you should leave them alone. If you try to do anything with them, you will get a nice angry ouch and a warning. Should you ever want to make a change to your design table, head to the Configuration Manager tab, expand the Tables folder, then right-click the design table, and Edit in New Window. When you're done, just save and close, and everything should update. Whew! Now that was amazing. We are now using the great and mathemagical powers of Excel to drive our SOLIDWORKS part. Sweet.